So children, we continue our discussion on chemical equilibrium. We are still in heading number 5, that is law of mass action, that is law of equilibrium. In the law of equilibrium or law of mass action, we have done the derivation of Kc, we have done the derivation of Kp, and we have seen the relation between Kc and Kp. And meanwhile, we have also learned one very important term called as reaction quotient or concentration quotient, right? Now I am coming to the next aspect, and that is general. So we are continuing heading number 5, general characteristics of equilibrium constant. In fact, whatever you have discussed, if you think, whatever you have discussed so far, if you think about them properly, you will be able to write the general characteristics on your own. All right. So I will first just tell you what are the general characteristics, and then I'll read out from my notes so that you can make your notes in a proper way. Now, first and foremost thing, I would say that point number 1, the value of equilibrium constant will remain a constant, at a given temperature, which means the value of equilibrium constant, whether Kc or Kp, it can change only when the temperature is changing. Otherwise, that value will be always constant at a particular temperature. Now coming to point number 2. Point number 2, suppose there is an equilibrium and you are changing the concentration. So will the equilibrium constant will change? No. I'll just tell you in a very simple language. The value of equilibrium constant will remain constant in spite of changing the concentration, or you can say pressure of any reactant, I'm writing in capital, or any product. What I mean is, suppose there is the reaction A and B are in equilibrium with C and D. All right. To keep it simple, I am not writing the numbers to balance it. Just keep it simple. 1 mole of A giving and 1 mole of B are giving me 1 mole of C and 1 mole of D. I want to understand it properly. So I say Kc is equal to concentration of C into concentration of D upon concentration of A into concentration of B. Let's say value of Kc is 100. All right. Just for the sake of discussion, let's say it is 100. Now my point is, suppose you add some C. So there will be tendency for Kc to increase. But the moment you add some C, so some of the C will react with some of the D to give you some little bit of A and little bit of B. In other words, if तुम अगर बाहर से C या D को बढ़ा दिया, तो C और D अपने आप रिएक्ट करके A और B बनेगा, तो A वैल्यू कम हो जाएगा और ये वैल्यू बढ़ जाएगा, in such a manner that the value of Kc remains 100. That is the idea of equilibrium constant at a given temperature. Similarly, at the same temperature, suppose from outside you have increased the value of A, तुमने थोड़ा A डाल दिया, तो immediately if the A increases, the value of Kc will tend to decrease from 100, but it will not allow. What will happen? Some of the A and B will react to give you some more C and D. That's so that the little bit of added value of A has become less, a little bit of B also has become less. Meanwhile, amount of C and D have become more, in such a manner that the value of Kc remains constant. So the point is this: the equilibrium constant will remain constant whether you change the concentration of or pressure of any of the reactants or any of the products at a given temperature. Then there is another thing I must tell you, point number 3, that when you write this equilibrium constant, so when you write the equilibrium constant, so for any anything which is in the solution state or in the gaseous state, so their concentration value or pressure value will come in the picture. So their values will come in the picture. But if anything is present in the form of solid or in the form of pure liquid, then their values will be taken as 1. They will not contribute to the value of Kc. What I mean is, suppose there is a reaction. Again, I will write it like this. A and B are reacting to give me C and D. Let's say A is in the aqueous state, B is in the aqueous state, C is in the solid state. This form the precipitate and this is in the aqueous state. So initially we will write Kc is equal to concentration of C into concentration of D upon concentration of A into concentration of B. But this value of C you will be taking as 1 because it is present as solid. So it will be 1 into concentration of D upon concentration of A into concentration of B, and that means it will become concentration of D upon concentration of A into concentration of B. That means in simple language what I would say, if anything is present in the solid or in the pure liquid state, then uska concentration question does not arise, because concentration of anything is discussed with respect to a medium. So if existing in the form of pure solid, so it is not mixed with the medium. So where is the question of its concentration? Of anything is present in the form of pure liquid, so it is just a pure liquid, it is not present in any medium, so its concentration का question नहीं आता है. तो अभी question of their concentration जब नहीं आता है, तो तब you have to ignore it, and the best way to ignore it is don't take it as 0, then everything will get nullified. Then take their value as 1. So that is the point, that when you write the equilibrium constant for solution and gases, concentration terms will be taken in suitable units. But if there is a solid or liquid, pure liquid, then their concentration is taken as 1, and very smartly they are thrown out of the picture. So that is point number 3. Then coming to point number 4. Point number 4, that the presence of catalyst will not have any effect on the value of Kc or Kp. What happens if you use a catalyst? Only thing is, both rate of forward and backward reaction will increase, and therefore the equilibrium will be attained very fast. But the concentration, the ratio of the concentration of products to the concentration of reactants raised to the suitable power according to their stoichiometric coefficient in the balanced equation will remain the same. तो खाली क्या होता है, वो रिएक्शन जल्दी जल्दी खत्म हो जाएगा, मतलब इक्विलिब्रियम में आ जाएगा. बट आने के बाद जो कॉन्सेंट्रेशन ऑफ प्रोडक्ट होना चाहिए, जो कॉन्सेंट्रेशन ऑफ रिएक्टेंट होना चाहिए, वही रहेगा, एंड देयरफॉर the ratio of the concentration of product to the concentration of reactant will remain the same. So presence of catalyst has no effect on the value of, it has got no effect on the value of K, that is equilibrium constant, with the Kc or Kp, जो भी तुम बोलो. Then point number 5. Point number 5 is about the unit of Kc or Kp. We do not use. Generally, we do not use the value of unit of Kc or Kp. And coming to the point number 6. Point number 6 is this: the equilibrium constant, that is Kc or Kp. The expression, the unit of the expression of Kc or Kp will depend upon the manner in which the equation is written. Okay, the expression of Kc or Kp will totally depend upon the manner in which the equation is written. I will explain it with example, then you will understand it better. So when I write it, so I'll write it in this manner. Yeah. So I'll write for number 6. So I'm rubbing it off so that for number 6 I can write the example. So just see this carefully. See this carefully. So number 6. Let's say there is an equation. Example. Now, example. Point number 1. I write this reaction. There is N2O4 gas is in equilibrium with 2NO2 gas. So if I write in terms of Kc, in terms of the concentration, let us say I write in terms of concentration. So the Kc will be concentration of NO2 into concentration of NO2, that is square, upon N2O4. This is what I'll be writing it. But if the same reaction is written in this manner, now number 2, if the reaction, if the equation is written or balanced as, say, half of N2O4 gas is in equilibrium with NO2 gas, in that case what will be the Kc? The Kc will be, equation वही है but balance मैंने अलग तरीके से किया. So Kc will become NO2 upon N2O4 raised to half. So this is what will be the, and this Kc, another Kc I have written, so K dash C, let us say. Is that okay? Now I will show you one more thing. Point number 3. Point number 3, I hope you can see this. Point number 3, suppose this first equation I have written ulta karke, that is 2NO2 gas is in equilibrium with N2O4 gas. Then what will be the equilibrium constant? Now this will be Kc double dash, let us say, is equal to concentration of N2O4 upon concentration of NO2 square. Is that okay with you? Now if you see the first one and the third one, so how do you relate? So in that case, the relation between Kc and Kc double dash, what it will be? You will find that Kc is equal to 1 upon Kc double dash, because the reaction is ulta. Is it okay with you? So that is what is point number 6. Now I will read out from my notes so that you can understand all the 6 points properly. So point number 1, the value of equilibrium constant remains constant at a given temperature. It means the value of equilibrium constant depends upon temperature. Second point, point number 2, change in concentration, pressure and volume of reactants or products cannot alter the magnitude of equilibrium constant, because immediately the reaction, as I said, if you added reactant, it will go more in the forward direction. If you added product, more in the backward direction. But they will make sure that the ratio of the concentration of products to the concentration of reactants remain the same. Point number 3, the expression of equilibrium constant may contain the concentration of molecules in the solution. That is, if it is present in the solution state. It may also contain the concentration of gaseous molecules, okay, in the gaseous state, whatever. However, it does not contain the concentration of pure solid and pure liquid, as their concentration is taken as unit or 1. I told you that if pure solid, pure liquid comes, their concentration question doesn't arise. So we throw them out by saying their concentration is 1. So it is a very smart way of ignoring their concentration. Point number 4, a catalyst helps to achieve equilibrium faster, but it has no effect on the equilibrium constant value. Point number 5, generally we don't use the unit for Kc and Kp, which I have told you before. And point number 6, the equilibrium constant expression and value of equilibrium depends on the manner in which we balance the chemical equation. And that is what I told you, example 1, 2 and 3. And if you see 1 and 3, they are the exactly opposite way written. So the Kc is inverse of K double dash C, or K double dash C will be inverse of Kc. So that is all about it. Now I have to come to the application or uses of equilibrium constant. So the next discussion is application or uses of equilibrium constant. Now this aspect I'll be discussing it in the next video. Is it okay, children? It will be a small video, but I'll make a separate video for that. Thank you. Thanks a lot. God bless you.